Today we are talking about DJI O3 and image stabilization. O3 is the only FPV system today that has built-in image stabilization, allowing you to record your footage on board the air unit with DJI Rocksteady, or even export your footage and allow you to stabilize it later in GyroFlow. As a result of it having that built-in image stabilization, you can though come up against some problems you may not have had in the FPV system before, and that is the system picking up vibrations and that affecting how well your system image stabilizes. What we're going to do today is walk you through the things you need to check to hopefully be able to diagnose any problems you might be having with either Rocksteady or GyroFlow as a result of there being vibrations in the footage. There are some common things that you need to check, but we're also going to cover some of the less common issues as well, including tearing the O3 camera down to check that its lens isn't loose. We're also today going to upgrade the vibration isolation on the Nazgul you're seeing in front of me here, because at release iFlight sent this drone out with TPU mounts, but they're now issuing new silicon mounts as well, and we're going to take a look at that at the end of this video. The idea of this one is to hopefully inform you of the common issues that there might be and show you how to resolve them, and hopefully by the end you'd have found a way of solving problems that you may be having. If you find this video useful, please do consider checking out the links to my Patreon in the description. I want to say a massive thank you to all of my patrons. I would not have been able to keep making content on this channel without their support, and hopefully by the end of this video, if you do find it useful, you might consider checking it out. Anyway, let's get on with it and let's talk about what the common issues are first of all. Now, there are a few different things that might be causing vibration on your footage on the O3 system. Some of it will be hardware, but some of it could actually be software settings. For instance, DJI actually have a dedicated installation guide for O3 where they walk you through some of the issues and some things to check. We're going to talk about these in this video, but we're also going to talk about some of the other things that you can take a look at as well that might be causing you problems. My advice to doing the diagnostic on this is work your way through a process of elimination. The first thing you're going to want to look at is the mounting of your camera. Is it hard mounted, soft mounted? And if it's soft mounted, is it solid? Is there any movement? Is it loose? But also, is that soft mounting up to the task? For instance, this is the new iFlight Nazgul Evoke version 2. This has the O3 FPV system built in as standard, and iFlight actually built this frame with vibration isolation built in for the camera with little TPU mounts. Whilst that did offer some isolation from the vibrations of the frame, it turns out that that wasn't completely optimal, and iFlight now have upgraded those TPU mounts to silicon rubber ones, and they've sent me a set here, and what we're going to do is install these in this frame to try and improve its performance. Now, rather than actually doing that mount change at this point in the video, I'm going to do it at the end and continue right now with the things that you can check to help improve the footage output from the O3 system. Now, after checking your camera, the next task is to check your quad, because don't underestimate the effect of damaged props, bent props, or even loose components on the quad can have on the O3 system. You want to be checking that there's no damage or your props are not causing anything excessive. So if your props are a bit bashed up, swap them out, make sure they're in tip-top condition. Check your motor bells, make sure that there's no damage on them, making sure that everything feels good. Spin each one at a time. You should know how your motors will feel, but what they should more than anything is all feel very similar. If you're new to FPV, what you want to be checking is that they all spin about the same, they all run about the same, so you can see how much they're overrunning there with a flick, and there isn't one that stops instantly the second you leave go. If all of that feels good, you then want to be making sure that your frame is solid, none of your arms are loose, there's nothing catching anywhere. Things even like antennas down here can cause vibration, so check your antennas on the back are good as well, your mounts, and that everything on the frame is as solid as it can be. There are some frames that will always have more vibration than others due to either poor design or just the inherent way they've been put together, but what you want to be making sure is that there's nothing hanging off it and nothing causing excessive vibrations that shouldn't be there. So, as I've said, the camera mount is important. The reason it's important is because the O3 system has a gyro sensor built in, which is used for picking up that image stabilization data, whether you're using the built-in Rocksteady or the GyroFlow software. If you've done all of the checks on your camera, it's not loose, it's not moving around, and it's got isolation, the next thing you can do is check your PWM frequency. Now, the DJI O3 system is slightly unusual compared to some of the other systems out there in the sense that it has that gyro sensor, as I've mentioned, but it's built into the camera. That is used to provide that gyro data, but that means that the camera is susceptible to picking up vibrations either from your system or frame. With the O3 system, there is a known issue that the camera PWM frequency, basically the resonance frequency, is about 24 kilohertz. That is the same as pretty much most ESC frequencies. As a result of that, there is the possibility that your ESC frequency being 24 kilohertz is going to affect the output of your footage and cause vibrations. What you can do to resolve this is change your PWM frequency from 24 kilohertz to 48 kilohertz. You'll need to do this in your BLHeli software, and we'll take a look at that in a minute. But what it should then do is prevent you getting that vibrations on the footage affecting the gyro data. If you've done the camera checks and you're still getting issues, changing the PWM frequency is definitely the next step, and I'll walk you through doing that now. One thing to note is changing your PWM frequency up from 24 to 48 kilohertz is generally going to take away some of the responsiveness of the craft, just make it a bit less aggressive, more smoother overall. I'll be honest, on an O3 based quad, I really don't see that as a big issue. For most people who are trying to get the footage out of the O3 system, they're certainly not bando bashing it. They're probably wanting something that's going to give them a more cinematic look. And as a result of that, changing up to the 48 kilohertz PWM frequency shouldn't really be an issue. Obviously, some people will want to go bando bashing with it, and doing that isn't going to be the greatest result for them. They're the ones, though, who are going to have to try and find the right compromise. Anyway, let's hop over to BLHeli and take a look at what we need to do. Now, to do this, you're going to need the BLHeli configurator, and I'll put a link to this in the description of the video. You're going to need a flight battery, and you're going to need your USB cable to your PC. The first thing you're going to want to do is make sure that you're doing this as safely as you can, and that is you need to remove your props, because to be able to connect to your ESC, you not only need USB, you also need power as well. I'm also going to be using this, which is a short saver. This is an additional layer of protection, meaning that I'm not going to be able to accidentally trigger anything, even if I was to leave the props on. However, you never power up an aircraft, especially connecting it to a configurator, without taking the props off first, because you simply don't know how it's going to react. If you are going to do it, at least have something like this, which is going to cut the power if there's too much current. What this will allow me to do is power the aircraft on, even with the props fitted, but it will cut at 2 amp, meaning that the battery is not going to be able to power that aircraft should something go wrong. But you don't want to flash firmware with one of these in, because it could lead to a power loss, resulting in a bad flash or a brick. So what we'll do is we'll connect the USB into our flight controller, then we will get the battery connected up, and then we'll hop over to the app. Okay, so what you're going to do is download and open the BLHeli suite. You're going to connect down here, and then we're going to read setup from the ESC. As I've said already, you do need the power to be on for this, so please do make sure you remove your props, and if you're not, please do take precautions, such as using a short saver like I am here, which will prevent the aircraft spooling up. So as you can see, it's now read in the settings from the ESC. And if we look over here, you can see that the PWM frequency over here is currently set to 24 kilohertz. As I've said, this happens to be the same resonance frequency as the IMU in the O3 ear unit. DJI don't appear to have very much filtering on that IMU sensor, and as a result, it does pick up interference if your ESC is on the same frequency. So to do this, you would simply then change that up to 48 kilohertz. That way then you would have that out of the way. Then you would go down to write setup. That would then write those settings to the ESC and move that frequency out the way of the O3 camera. Now, if everything you've done hasn't helped, the last thing you could check is how tight the camera is in its housing, but also the lens. Now, I'll be honest, this should be the last thing you do. It should not be something you go to do first of all. What you're going to need to do first of all is, though, take the back cover off the O3 camera. You do this just by removing the 2 screws on either side that hold the rear housing in place. Once you do this, you can then withdraw the back of the camera from the front, and then that will allow you to very carefully pop off the connection that's down here. We're going to get a set of tweezers to do this. So we're going to carefully lift on either side, pop our cable off, and then that will reveal the inside of the camera with the main board itself. Now, the IMU in the O3 camera is actually located under this little DJI sticker here. If I lift this off, you will see that there's a little chipset underneath, and that is the main sensor that is picking up the gyro data for the image stabilization. Now, there are a few things in here that could affect the performance of that. First would be if your main board here is loose. So this is held in place with 4 screws, 1 on each corner. So if this board was able to move inside the camera housing, that would cause vibrations that would affect the IMU's data. There is also something else you can check, and that is that the lens is tight on the camera. To do this, you need to remove the 4 screws and withdraw the board. Once the screws are out, you can then carefully withdraw the camera from the housing, and that will reveal the lens. Now, what you're looking for at this point is if this lens is loose on the body. On mine, that is completely solid. There is no problems there at all. But what you want to be checking that nothing here is loose, nothing here is vibrating, affecting the footage. If all of that looks good, you can then simply replace the camera back in the body, put your 4 screws back in place, and at this point it's an opportunity to make sure that you've done these as tight as you can and that there's no chance that your camera is going to be vibrating in its housing. Now, just before you do put that back cover back on, you just want to make sure the heat transfer compound that is here is in place and it is all bunched up so it touches that little bit of metal on the back. What I've done is simply moved it all towards the middle, bunched it up into a bit of a lump. That way, when I press on this piece at the back, when I push it back on, that compound will spread again, and it's giving us good thermal conductivity. It's given us good thermal conductivity from that PCB to the back cover, helping keeping the camera cool. Okay, so the last task for me to do on my aircraft is to replace these mounts. Now, as I've said, the original mounts that came on the Nazgul were TPU, but we now have these new silicon rubber ones, and that's what we're going to use. To do this, you're going to need to undo the O3 camera. What I don't know at this point is if there's enough cable in there for me to withdraw the camera forward, pop the mount out and pop it back in. That we're just going to have to try as we go along. So what I'm going to do is get my screwdriver set up ready to go with the correct sizing. I always tend to use this driver from Tarot RC. This is really one of my favorite tools. It's a multi-tool. Ben at 3DXR gave me this one, and it allows me to quickly swap between ends, but it's also got a lot of nice length on it as well, allowing me to easily get next to motors and things like that. So what we're going to do is undo and remove the 4 screws, 2 on either side of the main camera. Okay, they're now out, and what I'm going to do is carefully just try and lift the camera forward out of the way. There we go. I have enough space just from the looks of it to get that out. Let me just zoom in so you can see a bit closer. So there we go. I can just lift the camera up out the way, and I'm just going to push the TPU pieces from each side. They'll fall through the bottom, and there you can see they've come out. And if we now take our new ones and place them next to them, we'll be able just to see the difference between the two. Just looking at the hardness differences, if I just take my driver and press on that, you can see it's quite soft, whereas this is a hard TPU. It's not solid. I don't know what the shore hardness is on this, but it's not going to offer the same level of vibration isolation that you get in from these silicone mounts. It's definitely a big difference when I push between the two. So the process then is simply the reverse. So what we're going to do is lift the camera up and pop each side in. Here we go. I'm then going to just put the camera between the two and then replace the screws. Now, just something to note on these rubber mounts compared to the TPU. Whereas before the screw would bottom out on the TPU and stop, now you can screw it all the way in and it will start to crush the silicone rubber until it bottoms out on the camera. You don't want to tighten these up so much that the mount is being squished. You want it so it's just holding the camera tight, but you can adjust it if you wanted to, and that's where I've got it there. You can see the difference in the silicone now compared to the TPU. If I wobble it, you can see that there is movement there, so it's going to offer a lot more vibration isolation in use. There we go, so it's all done. The camera's nice and tight. It's not going to vibrate simply through its own movement, but it's got those new silicone rubber isolators, which just should help dampen anything making it through to that camera. Okay, so hopefully that's given you an idea of some things to check if you are getting problems. The very basics are, start with the camera's mounting. Is it hard? Is it soft mounted? If it's soft mounted, is that mounting able to absorb any vibrations from your frame? Is it TPU? Is it softer rubber or silicone? Something like that. Then you can move on to looking at your PWM frequency, and then if you're still having problems, you need to dive deeper. Is your frame damaged? Is there any vibrations off motors that are damaged? Or is this something such as a loose lens on the camera? You need to go through all of the things to check what's going on before you hopefully then will find the solution. Remember, any damaged props, any damaged motors or frame is going to have a massive effect as well. So don't overlook anything such as an arm that might feel slightly loose or a motor bell that has a bit of a ding in it. The O3 system has huge capabilities, but it is going to need basically the perfect setup to give you the best possible performance. In the end, if you're still having issues after all of that, the chances are your frame is probably just not very good from a vibration point of view, and you might want to consider looking at some other frames out there like the iFlight frames that I've got here, or even better, some of the ones from Chris Rosser, such as the AOS's, which have been specifically designed for vibration isolation and being able to actually reduce the amount of vibration that you get in your build. Now, if you have found this video useful, please do let me know what you think in the comment section. Furthermore, if you'd like to support the channel to allow us to keep making content like this, please do consider checking out the link in the description to my Patreon. It's only through the support of my patrons am I able to keep making content like this, and if you think you'd like to support us, please do consider checking it out. Anyway, that's it from me on this one. Please do stay safe. Please do let me know what you think in the comment section, and I will speak to you soon.